Automatic, Addison.
In this tutorial, I will guide you through the core concepts of the MoveIt Task Constructor for ROS 2. You will also install it on your computer. The MoveIt 2 Task Constructor is designed to make complex robot tasks easier to program and manage. At its core, the Task Constructor breaks big tasks into smaller, more manageable pieces called stages. These stages can be mixed and matched like building blocks. They can also share information with each other, making it easier to create smooth, coordinated robot actions. Overall, the goal of the MoveIt Task Constructor is to give robot programmers a set of tools that make their job more efficient and help them create more reliable and adaptable robot behaviors. The MoveIt Task Constructor is built around three core concepts that work together in harmony to create a comprehensive system for robot task planning. First, we have the task. A task is like a big plan for a robot. It is made up of a series of smaller steps that the robot needs to do to complete a job. Think of a task as a recipe for the robot to follow. Each task is built from a sequence of stages, which are the individual steps or actions the robot needs to take. A stage is a simple step within a task. It is a specific action or calculation the robot needs to perform. For example, a stage might be move the arm to a certain position or open the gripper. Stages can be simple or complex, and they work together to form the complete task. Each stage produces what's called a sub-solution, which is the result of that particular step. In the previous tutorial, you had experience adding a collision object to the planning scene. The planning scene is the virtual model of the robot's world. It includes information about the robot itself, any objects in its environment, and any constraints or rules the robot needs to follow. When the robot is planning its movements or actions, MoveIt uses this planning scene to figure out what the robot can and cannot do. The planning scene gets updated as the robot moves through its task, keeping track of changes in the environment. Let's take a closer look at the stages of the MoveIt Task Constructor, courtesy of this image by Picnic Robotics. So the MoveIt Task Constructor uses different types of stages to handle various aspects of task planning. These stage types are designed to work together, providing a versatile toolkit for creating complex robot behaviors. And we're going to discuss the three main types of stages: the generator stage, the propagator stage, and the connector stage. So it's generator stage, propagator stage, and connector stage. Remember those terms. And we're going to walk through each one bit by bit, step by step. So the generator stage, okay, so let's start with that one. This stage receives no input from adjacent stages. It doesn't care what happens before it or after it. So the results that are computed in this stage are passed forward and backwards, as you can see in the image on the upper left. You see those arrows going up and down from the center part. So remember that it's the results in that stage are computed in the stage, and then they're passed forward and backwards in the process. Let's look at some examples of generator stage types. Current state is the most important generator stage. This is like taking a snapshot of where the robot is right now. It captures the robot's current position, the state of its joints, and any objects it might be holding or interacting with. Current state generates the starting point for planning what the robot will do next. The next example is generate pose. Generate pose is another type of generator stage. Generate pose is about coming up with possible positions for the robot's arm or gripper. For example, if the robot needs to pick up an object, generate pose might generate different ways the gripper could be positioned to grab the object. It's like brainstorming potential positions for the robot. A propagator stage is like a one-way street. It receives an input from an adjacent stage, processes that input, and then generates an output for the next stage. And let's take a look at some examples. Move to is a propagating stage type because it takes the robot arm's current state as input and produces a new state as output. For example, the move to stage might start with the arm at rest and end with the arm reaching into a parts bin. Another example is move relative. Move relative is another propagating stage type because it advances the robot's state incrementally. It takes the current arm position as input and outputs a new position based on a relative movement. For example, during the move relative stage, the arm might move, let's say 10 centimeters upward relative to where it currently is in the world, propagating the state forward by this small relative change. And then our final example is modify planning scene. Modify planning scene takes the current planning scene, let's say the virtual model of the robot's environment, as input, okay, along with pre-programmed instructions for how to modify that scene, such as adding or removing objects from the virtual environment. It then outputs an updated planning scene. Unlike propagators, connectors do not send results to other stages. Instead, they are like bridges that plan movements between two arbitrary stages. An example of a connector stage is finding a way to move the arm from its current position to a specific point. These three stage classes we mentioned are called primitive stage classes. They are the basic building blocks for tasks in MoveIt 2. MoveIt Task Constructor has a concept called containers. A container is like a box that can hold one or more stages or even other containers. It helps group related stages together and create a hierarchy or structure for complex tasks. There are three types of container stages: wrapper, serial, and parallel. Let's go through each one. Let's start with the wrapper container. This container is used to modify or filter the solutions of the stage it contains. The wrapper modifies how a single task is performed without changing the core action. So, for example, we could have a wrap a pose generator with an inverse kinematics solver. So to begin, we have a pose generator, okay, which is a component that comes up with possible positions and orientation for the robot's end effector, like a hand or a gripper, okay, and that's used to grasp the object. Then you would have the IK solver, inverse kinematic solver, which would figure out how the robot's joints should be positioned to achieve the specific end effector, the gripper, pose calculated in number 1 in the pose generation piece. And now by wrapping the pose generator in that first step, okay, with the IK solver, the inverse kinematic solver in step 2, you're creating a system that not only generates potential grasping poses, but also immediately checks if the robot can actually achieve these poses, ensuring that only reachable and feasible grasping positions are considered. Let's move on to serial containers. This container contains a sequence of stages that must be followed in order. Here's an example, okay? Step 1, approach the object. That's stage 1, propagator. Step 2, generate the grasp pose. That's stage 2, generator. Step 3, grasp the object. Stage 3, okay, that's propagator phase. Then you have stage 4, which is lift the object, okay? Lift the object. That's another propagator stage. The robot needs to complete all these steps in sequence to successfully complete the task. That's a serial container, in order. Stages that must be followed in order. 1, 2, 3, 4, blah, 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 blah. Next up, we have parallel containers. This container allows for the simultaneous or alternative execution of multiple stages. It can include alternative stages, fallback stages, or merger stages. Let's start with alternative stages. Alternative stages are different options to achieve the same goal, where only one needs to succeed. For example, you might have stages for picking an object with either the left hand or the right hand. The task will be successful if the robot can pick with either hand. Fallback stages. Fallback stages are backup options that are tried in order if earlier ones fail. For instance, you might have a default motion planner, and if that doesn't work, it will try alternative planners. This ensures that even if the preferred method fails, there are other ways to complete the task. Now we've got merger stages. Merger stages allow multiple distinct actions to happen at the same time. For example, the robot could open its gripper while simultaneously moving its arm to a new position. This can make tasks more efficient by combining compatible actions. Parallel containers give flexibility in how tasks are performed, allowing for multiple approaches, backup plans, and simultaneous actions. This makes robotic tasks more adaptable and robust. Have a look at this diagram and see how containers and stage types could be organized in a simple pick-and-place application. So that covers the basic concepts of the MoveIt Task Constructor. If you want to do further reading, you can go to the official MoveIt 2 website. Let's start our hands-on experience by creating a new package for our MoveIt 2 Task Constructor code. Open a terminal window and navigate to the My Cobot ROS 2 directory in your ROS 2 workspace. Now let's create a package using the ROS2 command line tools. ROS2 package create, build type, amend CMake, dependencies, generate parameter, library, MoveIt core, MoveIt ROS planning interface, RCL CPP, license, BSD, 3, clause, maintainer, name, Ubuntu, maintainer email, automatic Addison at todo.com, node name, alternative path costs, my cobot MTC demos. Enter. Okay, let's CD to the workspace. Excuse me. All right, and now let's check for dependencies. Let's do ROS dep install from paths src, ignore src ry. Okay, all required dependencies have been installed. Now let's build. And before we do that, as I always say, I've got this build alias that CDs to the workspace, runs :build, and then sources the bash RC. Let's do that now. Open a terminal and type build. Okay, folks, now it's time to go through the installation process for the MoveIt Task Constructor. Follow along, click by click, keystroke by keystroke. Remember, slow is smooth, smooth is fast. So first we need to install the Warehouse ROS Mongo package. What is that? Okay, the Warehouse ROS Mongo package is a database tool for ROS2 that allows you to save, retrieve, and manage important information about your robot's positions and configurations, acting like a digital memory bank for your robot. So we've got a terminal window open, and let's begin by installing some system-level dependencies needed by the Warehouse ROS Mongo package. I'm going to go sudo apt-get install gnupg and then curl. Okay, it's already installed. So let's now install MongoDB. Let's walk through the whole process together. Going to start by going to the website, and I'm going to go to Google, install MongoDB Ubuntu. It's this guy right there. Okay, and we're going to, why is this dark? It's just dark like that. Oh, cookies. Oh, the cookies confirm my choices. There you go. Okay, we're going to be following this particular guide. Okay, we did this step, the installation. All right, now let's go to, I'm going to open up a terminal window. Let's begin by going to CD downloads. Let's go over here. Going to copy this. So remember this URL because we're going to be installing version 8, but this is likely going to be changing in the future with different versions of Ubuntu, but the process will be pretty much the same. So we're going to be installing right now the public key, copy, Go over here, paste this nasty command, and press enter. All right. Now, what does it tell us to do next? Create the list file, etc, apt, all of that stuff. All right, so what we need to do is I'm going to click that. Let's go over here and paste. And here's how the command should look. Okay, press enter. What's next? Install, let's see, issue the following command to reload the local package database. So let's copy that. Just paste, enter. Let it do its thing. All right, and let's go back here after we've done that. We need to, let's see. Now we need the latest release, so we're going to do sudo apt-get install y mongodb.org. Let's just copy this command. Let's go here and paste. It's going to be a lot of stuff, so just let it do its thing. Wait till it finishes installing. Okay. Now, what's next? What's next? What's next? Let's skip this piece. We don't need that. Now let's do this part. This starting the mongod process by using the following command. So sudo systemctl start mongod. Right click, paste, enter. All right, let's go over here. Verify that MongoDB has started successfully. So let's use this command. Status Mongo. Says active running. That's exactly what we want. And press Q to quit. Q on your keyboard. Okay. And that's pretty much it. Okay, so now let's go to navigate to your ROS2 workspace. Let's clear. CD ROS2 workspace. Okay, and we're going to do git clone. Let's go over here and just get the whole shebang. Let's go to Google warehouse ROS Mongo git ROS2. It's this guy right here. Let's go click ROS2. And I'm going to click this code green button. Let's highlight that. And so we have git clone. Okay, and then the URL, and then we want the ROS2 branch. So -b and then ROS2. Oh, before we do that, sorry guys. All right, let's copy this. We need to go to the source. So let's go not just to the workspace, let's go to the workspace source file, like there. Okay. If you already installed it in the root of the workspace, just delete it. You'll do the rm, okay, -rf, and then warehouse, blah, 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 blah. That's to remove it. You do that in the root of the workspace. Okay, so now we're in the ROS2 workspace, the source directory, and let's type the git clone command again. We just cloned. Now let's see if it's in there, warehouse Mongo. Now let's cd into it. Okay, we're into it now. And now I want you to do this command. Okay. Actually, before we go to do that, sorry guys, let's go to the commits. Okay, so we want to get this commit right here, this 32F8 FC5. This guy. Okay. And you can see up here, okay, I'll just go through that again so you see how I got there. All right, so we're at the main GitHub, right? We go to ROS2. Okay, you click 155. This commits, might be a different number by the time you get there, but click this commits. And we want this first one. We want this first one. I've tested it and it's compatible. So we click on that, and up here, you can see this full, long, ugly number up top here. We want that. We want that commit. So how do we do that? So we're in our warehouse ROS Mongo package. We need to do get. We need to do reset. And then hyphen hard. And now we need that big, long, nasty number. So I'm going to highlight that. Copy. And put it in here. Okay, now we've got it. So now we go to CD, ROS2 workspace. Let's do ROS dep update. Let it do its thing. Now let's do ROS dep install, and then from paths src, and then ignore src, and then -r-y. Okay, now let's do a colcon build. Let it build. See if it screams at us and gives us any errors. If it does, we'll just fix it. Should be okay. Okay, good. Built just fine. And let's just close out of that. Let's close out everything. All right, now it's time to install the MoveIt Task Constructor package. Open a terminal window. Go to ROS2 src. And let's just go here to Google. Type MoveIt Task Constructor. Open it up. Let's go down here to Jazzy because we're using ROS2 Jazzy. And let's click on commits. And I'm going to take the latest commit here. Let's click that hash. By the way, this guy changes the code all the time. And sometimes, you know, if you get the latest and greatest version commit of this ROS2 Jazzy package, MoveIt Task Constructor, things can break. And so you just need to be careful what hash you get. Sometimes he removes old hashes. He changes this a lot. So you got to be very careful. And the key is to just try different commits. I like to try the latest. If that doesn't work, try the one before that. But as of the date of this video, which is June 25th, 2025, I'm going to use this latest commit right here, which is this 3B2A436. So that's just one thing to look out for, especially when you're getting open source packages. Very common issue where the maintainer is constantly updating and sometimes improving things, sometimes not. And things can break. I've had a lot of experience with things breaking sometimes on using this MoveIt Task Constructor because you can see he makes changes quite a bit. Every few months he's making some changes. Even though the ROS2 Jazzy Distribution has, been stable for a couple years. He's still making changes here, so things can break. That's the thing to look out for if you come across this tutorial later on and you run into all sorts of build errors. So I'm going to use this particular hash. I'm going to highlight it up top, this 3B2A43, the latest one. Okay, let's go over here to the terminal. And I'm going to do a git clone. Actually, let's just go back here to the main one, and let's go to highlight this right here, this HTTP. Okay, and then we want the Jazzy branch, So we're going to do -b and then Jazzy. Okay, and they're going to cd into it. Now we're into it. And let's get the specific commit. So go click on commits. We're in the Jazzy branch. I'm going to get this one. Okay, and I'm going to highlight this 3B2A43, blah, 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 blah. Highlight that. Go to git reset -hard, and then this. Okay, here we go. So that worked out well. Let's go to cd ROS2 workspace. And now let's do ROS dep install, and then from from paths src -ignore -src -r-y. Okay, we need to install this particular tool right here. Type your password, install. Okay, that's good. Okay, my friend, now it's time to run colcon build. And this is going to take a while. Let it do its thing. That error on RViz marker tools, just ignore it. No biggie. It's going to take some time here to build, so feel free to go walk away, let it do its thing, and then come back when everything is processed. Okay, you're probably going to get some build errors. Very typical with this package. Lots of stuff screaming, even though we're just using regular ROS2 Jazzy. So when you get these build errors and warnings and stuff like that, you can see all this gobbledygook. Don't freak out. Don't freak out. Just clear. And now let's do a colcon build again. Okay, and you can see everything went through just fine. Let's source the bash. That's good. Now, one issue I found in the pick and place demo is that it works during the planning phase but fails during the execution phase. And this issue has been documented on GitHub. In fact, if you execute the plan via RViz, everything will work fine. If you execute it via the code, execution fails. You'll see a message that says stopping execution because the path to execute became invalid. So to fix this issue, we need to go to cd source MoveIt Task Constructor core src to get it storage. Okay, and let's go down in this document. Let's do a Control F. Okay, and let's do a get planning scene. Okay, let's see here. So you can see we've got this piece right here, this if, this end scene, get parent, this start scene, and then this end scene, get planning diff, all this gobbledygook, and else, all this stuff. Yeah, this caused me problems. So what I recommend you do is you just go to remove this line. Let's just do a delete there. Get rid of this else. Okay, so now we've got this end scene, get planning scene, diff message, and then t.scene diff right there. So you want this. So it looks like this. Here's how our code looks. Okay. And save. Close it. Now let's go to another piece. So let's go to CD ROS2 source, MoveIt Task Constructor, core, SRC solvers, get it Cartesian path.cpp. And let's go down here. Let's find jump threshold, Control F. Jump. This jump threshold I see has been changing around a lot. A lot in this guy's code. So this line right here where you see move it core, jump threshold, props, dot get double jump threshold is valid. I ran into some issues with that. So what you want to do is change it to move it core, jump threshold. Okay. And then let's go over here. Oops. Relative. Open parentheses. Props dot get double jump threshold is valid. So jump threshold, move it core, jump threshold, relative props dot get double. Save it. Close. Now open up a new terminal again and let's go to CD ROS2. And let's run a colcon build. You're going to let it do its thing. Okay, run colcon build again. And source the bash RC. Nice. All right, now let's update the package.xml. So cd source, cd mycobot ROS2, mycobot mtc demos, and get it package.xml. All right, we got generate parameter library, MoveIt core, MoveIt ROS planning interface. We need to add one more. Let's do depend. And let's add MoveIt Task Constructor core. And forward little alligator in the comment. Tell me what this thing is. This is a little less than sign and then / and then depend. All right. Good, good, good. Now let's save and close this. All right, let's do cd ROS2. And let's do ROS dep install. And then from paths src -- ignore src -r and then -y. Check for the dependencies. All good. All right. Good, good, good. Let's just do a quick build. All good. All right, now let's create a launch file that will handle the MoveIt Task Constructor demos. So let's do cd src mycobot ROS2 mycobot mtc demos. And let's create a folder named launch. Let's go in here. Let's do touch mtc _ demos .launch.py. And let's open it up. And let's go over here to our folder, and we've got our repository from GitHub. This is what I cloned into my downloads folder. You can find it on my GitHub. Let's go to launch. Let's open this puppy up. Oh, by the way, did we name that correctly? Let's go back here. .launch.py. Yeah, we did. Okay, let's open this guy up. Control A on that, Control C. Let's go over here at MTC Demos and Control V in here and save. Okay, there we got all of our stuff in here. Okay, let's add the RViz configuration file. Make dir RViz. Got it there. Go to cd RViz. Let's go to get it mtc _ demos.rviz. Go over here to the folder, downloads. Open that with get it. Always open with get it. Control A, Control C, and let's copy it into here. Okay, let's open CMakeLists.txt. Let's go down. We need to add these new folders, the launch and RViz. So just above the build testing, Okay, I want you to add this block. This block of code, I'll show you where it is, what we do here. Right there. So install and then directory, launch RViz, destination, share, project name. Right here. Just above the build testing, add this block right here. Take your time, no rush. All good. Okay, and save and close when you've done that. Okay, let's add the demo code. We're going to add it in the MyCobot ROS2, MyCobot ROS2 demos. MyCobot MTC demos. And we're going to go to the source folder. We've got this alternative path cost.cpp. Okay, let's go to the downloads, MyCobot. And let's go to MTC demos, source, add all of this stuff. Okay, and let's actually open another folder. Go to the ROS2, source, MyCobot ROS2, MyCobot MTC demos, source. Okay, let's just delete this guy right here. And we're going to highlight all of that code. These are demo files, by the way, that I have pulled and modified slightly from the MoveIt repo, official repo there. Modular, Cartesian, all good. Okay, so we copied and pasted over there. That adds the demo code. Okay, now what we need to do is let's go to ROS2 source, MyCobot ROS2, MTC demos, and open this CMakeLists.txt. Okay, yeah, it's missing all these new files that we just added. Just keep it open for now. Let's go over to the downloads. MyCobot. Open this CMake. And you can see here in the one that's from GitHub, we've got all of our stuff, all of our different files. Okay, these files, where are they? Match these modular, IK clearance call, fallbacks, all that. It matches what's actually in the source folder. Okay, so it's going to be easiest to just copy this whole thing and just paste into our repository here, our area where we're working, and save. So it look all good, yeah. Copy the whole thing, put it in. You don't need to all know all the nitty-gritty details and all that, but yeah, you feel free to just run it through your favored LLM if you want to get a more detailed explanation of each of the piece and how to write it and so forth. But yeah, you can see it right here. I've got pretty detailed comments that runs through what's going on. And let's save and then close. Okay, now let's open up a terminal window. Let's close some of this stuff. It's clear. Go back to the root. Okay, and I'm just going to go to the ROS workspace. Let's do a colcon build. And let's hope it builds. Let's see. Okay, and we've got some deprecations with .hpp. All right, and where do we go here? So it's inside the IK cost clearance. All right, so let's go over there. Let's go to ROS2, source, MyCobot ROS2, NTC demos, source, and which file? IK clearance cost, CPP, and it's screaming on line 19. Why is it screaming on 19? So it's saying home Ubuntu IK clear comments. Let's go take a look at that thing. IK clearance cost on line 19. So it's saying this HPP is deprecated. Use pound include. Okay, so it's saying to do this. Use pound include MyCobot. So it's telling us the error. So let's go up here and change this line 19 to this. By the way, by the time you're looking at this tutorial, all this will be fixed on GitHub, so you won't need to do this step. I'll make the update in GitHub. Let's save it. So here's the new line. Let's go back over and try to build. First, let's source /bashrc. Okay, and let's run a colcon build again. Okay, everything looked good. Okay, now we need to create a quick launch script here. cd source, cd mycobot ROS2, cd mycobot bring up, cd scripts, okay, and now we need to create touch mycobot _280 _mtc _demos.sh. MyCobot _280 _mtc _demos.sh. Add that puppy. All right, now let's go over to open this, downloads. Okay, and here we go. Here we go. So our quick launch script, which enables us to run all the different demos. And again, these demos are on the official MoveIt 2 tutorials. I just adapted it for my repository. It made it a little slicker and more flexible. So we're going to copy all this code and put it into our stuff here. Let's copy all that. Control C, Control V, save. Okay. So now we've got our quick launch script. And finally, what we'll do is let's add an alias to handle that. So edit .bashrc. And I like the aliases. They just make our lives easier. Okay, and what we're going to do is take a look at, we're going to add something below here. Like this minimized. Okay, it's going to go down here. Let's do that now. So I want you to clear, and I want you to type this command. Okay. Take your time. So it's echo, double quote, alias, mtc underscore demos equal single quote bash tilde / ROS2 underscore workspace source mycobot underscore ROS2 mycobot underscore bringup / scripts / mycobot underscore 280 underscore mtc underscore demos .sh single quote, double quote, then these two little greater than arrows, and then space, and then tilde, and then / .bash rc. You can pause the video and take a look at that. Make sure you got the command, and when you're ready, press enter. And let's check our bash rc to see if that has been added. And it has. Just pull it up a little bit. Right there. Don't need all that space. And save. That is it, my friends. You are now ready to start taking a closer look at the demo applications. And we will do just that in the following tutorials. Thank you for following this tutorial, and keep building.